Welcome to Engineering Innovations, the official podcast of Purdue University's Elmore Family School of Electrical and Computer Engineering. I'm your host, Kristin Malavenda, the Communications Director for the department. In each episode of Engineering Innovations, I'll sit down with faculty from Purdue ECE to talk about their path to becoming an engineer, the focus of their research, and the future of the field. Our guest today is Steven Pekarek, the Dr. Edmund O. Schweitzer III Professor of Electrical and Computer Engineering. That's a mouthful. Steven, thanks so much for joining me today.
Thank you, Kristin. It's a pleasure to be here.
So we're going to just start right back at the beginning and say, when did you first, looking back on it, when do you first think you showed signs that you were engineering, you were headed towards engineering?
Yeah, that's a good question. I think I kind of had the curiosity of engineering growing up. My parents were the result of the Depression. They were older when they had my brother and I. And one of the things associated with at least how they addressed the Depression and subsequently is they didn't throw things away, and we always kept and tried to maintain everything.
Yep.
And one of the things that they maintained was an old vacuum tube-based black and white television. That's what we grew up on even through high school. And that thing never worked. We always wanted it to work, but there were problems with it, and inevitably the vacuum tubes were broken. And so at that time, you could go to like a Radio Shack and get the tubes fixed. And so this was part of the process. My father would take apart the TV, and we'd get the vacuum tubes, figure out which ones were bad, and get the TV working. And also, coincidentally, whenever the Super Bowl was on and Dallas Cowboys were about to score on the Pittsburgh Steelers, all of a sudden the blender would turn on because Mom was making something and it would corrupt the signal on the TV. And my father had some engineering background and tried to explain that in terms of electromagnetic waves and what the functions of vacuum tubes were. And I think that just instilled a curiosity.
Yeah, and you had the opportunity to test those things out, too, from a young age.
Right.
Well, you earned 3 degrees from Purdue. You got your bachelor's, master's, PhD.
Yeah.
And what's the difference now between when you were an undergrad and a student moving through Purdue and what you see in the students today?
Of course, technology is a lot different. And it's there, I was coming in at a time when we had the Apple products and Macintosh was just getting installed and here in ECE, and that was some part of your curriculum, and you did some coding, and but here it's ubiquitous, and so everything associated with that technology and how you learn from things like YouTube or from the different sites for education, that all's changed, and how a student looks at where they get their information from, and what the expectations of presentation are. I think that's the biggest one that I've seen.
And your son, Ben, is one of our rock star undergrads. He's involved in everything. So he's heavily involved in Purdue Engineering Student Council. He's the president right now, I think. He's a College of Engineering ambassador. He's done undergraduate research, and he's a Purdue Engineering fellow. I'm sure there's more that I'm missing. When did you notice in him that maybe he would take a liking to engineering?
It's funny. I don't know exactly if you know for sure of, an engineering bent. He enjoyed learning. I think that's the biggest thing. And I think he also enjoyed some, wow facts. Like I remember when he was first growing up, he was probably I think he was in preschool, and I had talked to him about the speed of light. Just out of curiosity, and that time stands still if you move at the speed of light. And he had no idea what that meant, but he would talk about that forever. And I think from that perspective, early on in him getting a grasp of some just basic physics, I think he had an early interest, and probably
just that inquisitive mind helps a lot too.
Yeah.
So let's move on to your research. And I know a big focus of your research has been developing the technology so that electric vehicles can drive on a highway and be charged as they're doing that. How did that develop, and where is it headed?
Yeah. Well, I'm in the power and energy group here within ECE, which I think is one of the great groups on campus. We just have a dynamic group, and a colleague of mine, Dean Esius Alaprantis, and I were working with some civil engineers, Nadia Gritza and John Haddock, to explore electrified transportation and address questions about, what are the big issues? And the big issues in terms of EV adoption are cost associated mainly with the battery, and then range anxiety. And so from there, the discussions morphed more, and we worked with teams across the country. We're part of an NSF Aspire Center that's led out of Utah State, and they have extraordinary faculty, and there's faculty from Colorado Boulder, Colorado Springs, Auckland University, and together we've worked on the electrified transportation. And it just so happens Indiana has an excellent Department of Transportation, very forward thinking, and they were motivated by this and wanted to address what are key issues that Indiana could be looking at. And one of those is we really are a transportation hub.
Mm-hmm.
If you think of 65 or
Right.
70, if you're driving on there, you see this. And the question then is, well, how do you electrify those heavy-duty vehicles where the batteries are just immense, cost is high, you're taking away payload because you've got all this battery? And we moved relatively quickly to say, okay, is this financially feasible? And then if it's financially feasible, is it technically feasible? And we tried to make inroads in both those avenues, and it's been successful so far. We've developed some laboratory demonstrations, new technologies, translated that into some laboratories that are run by INDOT, and now it's going on the roadway just west of campus. And it's extremely exciting. We have, I would call the rest, the other four, the Fab Four, and I'm lucky to participate with them.
So you mentioned professors from other disciplines. How does the interdisciplinary nature of any kind of research help it?
Yeah. You're often confronted, the boundary conditions are such that it's natural. I'll tell stories about one of the earlier aspects that I focused on is electric motors and generators. And those that are familiar, for an electric vehicle, you have a propulsion drive. And one of the things associated with that is you'd like to reduce the size or the cost of that, but you're always at a thermal barrier. You're sitting there. If you do that and you pack that in, oftentimes what that means is you have additional losses, energy that's being translated into heat. So how do you handle that? And so it's a natural progression because I don't have the expertise in heat and how to handle that. I mean, I have some now from experience, but those that are really at the cutting edge of that enable then to solve those problems. And so that's been natural.
Has it changed over the years from when you first started as a professor to now, or have you always really taken advantage of interdisciplinary research? Because I know it's a big focus now.
Yeah, I think there is a focus. To me, it's always been somewhat of a natural, either the problems you're working on have conditions that you have to search that out, or the problems you're working on are tailored more to your expertise. And I've had a mix of those. I've solved just pure electrical engineering problems that really specialized within this subdiscipline. But in my experience, the problems often to get true solutions are interdisciplinary.
Now, you're talking about how Indiana on 65, it's the crossroads of America, I think they call it. And when you're driving there, there's always a ton of tractor trailers.
Mm-hmm.
So you're part of the team that's also going to work with Cummins, right, to try to develop the same technology, but for large vehicles like tractor trailers.
Yeah.
What are the unique challenges that presents?
Yeah, it's the power level. If you're taking a semi that's moving 65 miles an hour, you're talking about a tremendous amount of power to provide to that vehicle. It's on the order of 200 kilowatts. And doing so and doing that efficiently is one of the great challenges. And I had mentioned we have some great faculty. We also have Aaron Brovant, who I had forgot to mention as well, who's also on our team. I should have called us out to him as well. And he's been leading that Cummins effort and has been tremendous there.
Is this what all your research focuses on now, or do you have other areas that you're also working on?
No, I continue to work on electric motors and generators with Scott Sudoff, with Justin Weibel in mechanical engineering and that aspect. I also do work associated. It's kind of funny because I had mentioned that whole problem when you turn on a blender and your black and white TV would all of a sudden have snow or lines across it. Associated with what's called electromagnetic compatibility or interference. I work on that as well. That's associated with switching of power electronics. And so I work on that too.
How did you move towards research in transportation and electric vehicles?
Yeah, well, when I was a grad student, we did a lot of work on motors and generators. That was my advisor was Oleg Wazenchuk, who was a faculty here and now since retired, but his interest was on those areas and how to model motors and generators. And so that's a natural thing because motors, and at the time, 20 years ago, people were thinking, okay, how do we incorporate these best into vehicle systems and form electric vehicles? And so it kind of was this natural thing that we were doing that. And we've also worked, he and I and Scott Sudoff has also worked on electric ships and moving toward electric propulsion in ships. And so that was a natural progression as well.
What do you see on the future for your area of research? Like, what are we still reaching for that's may or may not happen?
Yeah, well, the electric vehicle, I'll just keep on that track, so to speak. The adoption rate of those does continue to increase worldwide, but the question is, how can we do that in a sustainable way, and how do you do this in such a way that is equitable? And so those are issues and challenges we're trying to address, and part of that is the electrified roadway. But part of the electrical roadway is how do you get the electric power there to support that, and how do you do that in a rural setting where you may not have that infrastructure yet, and how do you do these large infrastructure projects and make them cost effective and beneficial to society? I think those are, where we're headed, the questions that we have to answer.
So when you were going through school, did you always know you were going to go straight through and get your PhD? And then beyond that, how did you end up in academics as opposed to industry?
Yeah. Well, one of the things that was attractive to Purdue when I was coming through high school is Purdue had a very strong co-op program. And I was a co-op student for a company for 5 semesters and then worked for them for a year after graduation. And so associated with that, I kind of got the sense of what was going on in that industry. And there were mentors that really were interested in supporting my career path. And in parallel with that, in Purdue's curriculum, we had a bunch of very strong faculty. Some are still here. And, they were motivating as well. And so they really presented the opportunities that graduate school presents and the things that you get to work on and how you can be at the cutting edge of research. And, that was kind of a thing I had to struggle with at the time. Which path do you choose? And I chose the path of PhD in research, and I haven't looked back.
So you mentioned mentors. How have mentors helped you along the way, and how does that inform how you interact with your students?
Yeah. I think for faculty, at least for me, mentorship probably meant most of all a passion for what they were teaching. I guess I was mostly motivated and mostly, influenced by great teachers and those that were really dedicated to their craft, which I think it is a craft, and I think it requires development, and they had enthusiasm and can show there's something here that's extremely interesting that you can build your portfolio of experience on and do that successfully. And I think that's what the mentors were for me.
So getting back to your research, how much are undergrads involved in your research, or is it really just graduate students?
No, we have we have a great group of undergrads, and I think over my career, I've always tried to incorporate undergrads into the mix. I smile right now because we have Dionysius Alaprantis, myself, and Aaron Brovant have a group that are working on this electric vehicle project, and they've been instrumental. They're excellent, and we get to joke with them, and they make me laugh a lot.
Do they ever surprise you, like with an idea that maybe you hadn't thought of, or a different way of looking at things, or are they really just there kind of soaking up the information you have?
No, we have some remarkable students that have certainly pushed the envelope of our understanding, and really given the opportunity. It's amazing what our students can do in terms of what they can build, what they can code, how they can integrate some different technologies to really make your life easier. And so, yeah, that's, I think that it's been overall extremely positive.
And when you're doing research, inevitably you're going to run into roadblocks. How do you get around those roadblocks? And when you sense frustration in your students, how do you help them understand that it's not necessarily a bad thing to hit that roadblock?
I think I've been used to roadblocks because I was a cross-country runner. So you kind of build this. I had a cross-country coach that preached mental toughness. And so we were always running hill workouts. We were running all kinds of stuff. And so nothing seemed to be easy. And you had to, I think the preaching there is preaching patience and perseverance. And I think the key thing associated with getting into hurdles, and here we're talking in an engineering sense, when you're really on tough problems, these hurdles can last a year. And you have people asking for results, the people that support your research, and where are the results, and how do you do that? And the best thing you can do, I think, is maintain some balance in your life and try to address this in a reasonable way, but a well-disciplined way of each day. I think like writers who say they get up in the morning and write for 3 or 4 hours, that's what I do recommend is, early in the morning, focus on those problems that really need a lot of thought and work through that.
Do you think that's a lesson that not just undergrads, but grad students have to learn, how to just not completely get frustrated and give up and to find a different way?
Yeah, I think that is. I think that's true. And I think there's different paths to that. I think you would I think we have 120 faculty. They'd probably have 120 different answers to that. But I think the best thing we can do is provide us an understanding of how we do it, and maybe they mimic it, and maybe they find their own path. But yeah, I think the perseverance through problems and figuring that out is a grand challenge of graduate school.
When you're meeting students for the first time, what are the qualities you see in a person that you think, oh, they're going to make a good engineer?
Yeah, well, oftentimes my success, I really attribute to my students who have been extraordinary. And a lot of the recruiting I've done have been through our undergraduate programs, and students that have taken my class and then shown an interest in it, and then also shown, a true talent for trying to sort through and get to the engineering models and solving them, very effectively. And then knowing how I think and working, making sure that you have this sense that you can work together well. And that's kind of the process that I've been using in selecting students that have worked under me.
How did you end up, was it just your interest in electronics that got you into electrical engineering? Did you ever consider a different discipline in engineering?
Yeah. I guess when I was a freshman here, there was the freshman engineering, which now is first year engineering, and there were seminars associated with this. And, I think I had a preconceived notion of electrical engineering just from the experiences in my household, and nothing changed it.
Mm.
The electrical engineering lecture, I don't remember it even right now, but I remember being positively influenced, and nothing else overwhelmed me.
Right.
I had friends where it did. There were friends I had that were inspired by the aerospace lectures and the Neil Armstrong and the Cradle of Astronauts. That was extremely influential to them. To me, it was, less so.
The interesting thing about that, though, and I think one of the misconceptions about electrical and computer engineering is that think of an industry and you need electrical and computer engineers in that industry.
Yeah.
Do you think some students think it's too specialized?
Yeah, probably. I think so. I think it's had I think it's somewhat difficult sometimes to explain to people because it's not necessarily tactile.
Mm-hmm.
Some things are. You have your cell phone, you have your television, you have all of this. And you can say, yeah, electrical engineer is, design in this. But you don't really see the components inside necessarily. You don't get a sense for what's the engineering. You tell people you have this electromagnetic wave. I can't see that.
Right.
And so that might be a little bit harder sell.
Yeah.
I think traditionally also in television and other media, we've been, portrayed as nerds, which...
No.
Yeah, I think that's fine. I'm a nerd. I think we just to go with it, ride that wave.
Well, it's interesting because as the communications director for ECE, sometimes it's hard to translate the research a professor is doing and have the layperson understand how is this going to impact my life.
Yeah.
So you have to get creative to kind of show that connection.
Sure.
If you weren't an engineer, what would you be doing with your life?
Yeah, that's a good question. There's many different things that I've enjoyed. I enjoy sports, and I enjoy coaching. I've coached kids, and I could envision myself doing those type of activities. I also enjoy reading and writing. Like part of the thing that's attractive in a faculty position is you do get to write not only code but write papers,
right?
Which I continue to enjoy. But I could have seen doing some technical writing. I could have seen doing some sports commentating, even though I don't necessarily have the voice for it.
I think your voice sounds pretty good, actually. You could have done it. You could have done it. You mentioned earlier about having a balance in your life, and you mentioned some things that you enjoy doing. When you're not in the lab or focusing on engineering, what are you doing with your limited free time?
Yeah, well, I have a crazy dog, a Labradoodle, that requires like 6 to 10 miles a day. It seems like, she's, so I keep engaged with that and doing exercise and running. My wife and I play a lot of tennis and pickleball, and I've enjoyed sports. I follow a Premier League soccer. I follow a team called Tottenham. Mm-hmm. So I do that, and then I enjoy fly fishing.
Oh, really? Can you do that in Indiana?
Yeah.
Yeah.
Indiana has some brilliant smallmouth bass streams, including just east of campus here. There's a creek, Wildcat Creek, and just south of us is Sugar Creek. So, yeah, it's excellent.
And when you're reading, you mentioned you like reading. What kind of things? Is it nonfiction? Is it technical? Is it fiction? What do you like?
No, I like, when you have kids, at least when I was when we had kids in the house, I at least didn't have a lot of time for long books, but I would read short stories. So, and I had different authors. I liked Alice Munro as an author. I liked the writing in the New Yorker magazine. I liked some of the Civil War narratives also. So I got into the trilogy by Shelby Foote. I've been working on that for years. So those are kind of the things I've been reading.
That's great. Well, it's been great to get to know you a little better today.
Thank you.
Thanks so much for joining me.
Thank you. Thank you for your time.
And that wraps up this episode of Engineering Innovations. Big thank you to Steve Pekarek for sharing his expertise, passion, and the incredible work happening at the intersection of the physical and virtual. And if you enjoyed today's episode, which I'm sure you did, be sure to subscribe, rate, and leave a review. Engineering Innovations is available on YouTube, Apple Podcasts, and Spotify. Your feedback helps us bring you more captivating conversations with faculty from Purdue ECE. And to stay updated on upcoming episodes and to explore more about Purdue ECE, you can visit our website at purdue.edu/ECE or our social media as well. You can follow us on Facebook, X, Instagram, and LinkedIn. You can check the show notes for the links to that and for more information. And we'll be back in a month with another episode.